Welcome. This is the concluding class, part 5 of the most important class for moment of inertia. This all I told. See, note what we are doing. I already told you. See, already I told you previous part 4, that is last class. I already told what we are going to cover now. Therefore, you should not come to part 5 unless you go to part 4 first, previous class. Go to previous class, study thoroughly. There I told you about this OX and OY. It can be sometimes XXYY. This can be centroid G. Today's, right now, OX and OY are the two axes about which moment of inertia is required. This all I told last time. So, and including parallax theorem, now told many times. So, you first go to part 4, study thoroughly, then only come to part 5. Part 4, we finished rectangle. Many cases. I think around 10-12 cases I covered. That is all the basic concept. Okay, rectangle already over. Now, already over in previous class with many examples. Now, today, see, some random lamina here. See, this can be what? Rectangle, or it can be a right angle triangle, it can be isosceles triangle, it can be triangle in general, it can be a circle, it can be a semicircle, it can be a quadrant, and little more I will tell you, even it can be an I section or T section or L section, angle section, provided you know the properties. This I will explain it later, that how to use parallax theorem for built-up sections or for when rolled sections are used. Right now, leave it. Okay, now this all you will cover. See what now. So first go through previous class lecture 51. See, lecture 51, that is part 4, and then this class lecture 52, that is right now part 5. Next, lecture 53 onwards, next class onwards will be calculation of moment of inertia. Maybe I will upload one more class, final touches I may give for you. I won't tell part 6 there. I will give final touches, something I will give you for that one. Then we will start finding moment of inertia, marathon problems we will solve. Okay, now this is all clear now. See, centroid G, area A, this all told. I told unless you go to part 4, don't come to part 5. If you ignore part 4 and come here, if anything is not clear, you are responsible. You only are responsible for not understanding properly. I am helpless. As I told in my class, if you want to understand everything, you have to study. Okay, now I will start this one. Okay, we will start now. Triangle, case 1, right angle triangle. This is case 1. Now, example number 1 here. See, I will put example 1 for this. For case 1, example 1. Question dictated. See, I won't tell every time. This is the given question. See, this is given in the question. How? You write, imagine a triangle of 140 by 120 as shown in figure. Okay. Then let the distance of this point from here be 110. This is 80. So this all right here, everything here is given in the class. Later you have to get it based on the given question. So these are all given, remember. So now no one should ask, sir, how you got 110? Some distance, see, from the eye, from OX axis, it is 110. From OY axis, this is how much? 180. I will always give what? Vertical distance and horizontal distance. Okay. Now, by parallax theorem, moment of inertia I about any axis is I about any axis Ig plus A square. Sorry, now I should not tell. Moment of inertia of the area considered about an axis passing through its own centroid and parallel to the required axis. Area considered A. H, perpendicular distance from centroid of the component to the required axis. That is to be squared. What all I told, right? This I am telling since past 4-5 classes, or I think in the class I told more than 30-40 times. Okay, start. Now I about Ox, I about Oy. See, correct, clear, what to do? Mark centroid. See, centroid is not given. You see, blue, green color right here. Black is given. See, all the black values and black values are given. See, black values here are given. Whereas G, centroid, see, G, centroid of the component with the green color, that we are deciding. It is not given. We are deciding. Okay, start. See, 3 part. This, first of all, I won't waste time on explaining G here. Remember, 1 by 3, 2 by 3. 1 by 3, 2 by 3. If not clear, never come to my channel once again. Okay, start. First, see correctly what I am doing. I want I about Ox. First, about its own centroidal axis, parallel to Ox. 140 into 120 cube divided by 36. You know the formula. Area, half into 140 into 120 into, from centroid of the component to the required axis, see, perpendicular square. See, red color, into, see here, this distance square. That distance is 110 plus 1 by 3 of 120. 1 by 3 of 120. Oh, I think I took the, I interchange it. Okay. 1, 2, no, correct. 1 by, which one I wrote? I about Ox is 1 by 3 of 120. 2 by 3 will come later. It got interchanged here. Okay. No problem. I took actually, first I wrote about Oy. I think, now here I wrote Ox. There, okay, these things happen. I am correcting now. See, 140 into 120 cube by 36 plus area into this distance square is 110. Okay, I can make out here 110 plus 1 by 3 of 120 whole square. I told class after class from beginning of structural engineering, horizontal axis means vertical distance. Vertical axis means horizontal. So whenever you find I about Ox axis, that H is always vertical. See, from vertical. When you find I about Oy, that H is horizontal. Now I won't tell. Okay, start. Calculate the answer. Answer not required. I about Oy. See, first about its own centroidal axis. See here, this axis. 120 into 140 cube. This all I won't explain now. Why? Side parallel is 120. This all told many times. 120 into 140 cube by 36 plus area, half into base into height into 80. When I was writing here, I thought I am writing other way. Observation problem, not a technical mistake. Into, see, from centroid of the component to the axis. This distance is, see, this distance, 80 plus 2/3 of 140. 80 plus 2 by 3 of 140, that is to be squared. This is I about Y. Calculate the answer. Okay, now immediately example 2. See, what I will do is example 2. I will maintain same distances. This you should not do this way. You are trying the sketch once again. Remember, don't do this way. And what I will do is, I will place the same triangle 140 by, how much I told, 120. I won't change it. You write here, given question. Okay. Same 140 base, height 120, but see this side now. See, this is 120. This 140. Now last time it was this way, now this way. These all question is given. You write one more sketch. Okay, now immediately. See. It's centroid. G. Start. First I about OX. First I about its own axis. Parallel to OX. 140 into 120 cube by 36. This is to save the time. You take independent question every time you write it. Don't think, oh, same as last time. Okay. Then plus area. Half into 140 into 120 into, see, 110 plus 1/3 of 120. Oh, same answer. Okay, over. I about YY. See, I about YY. Oh, sorry, green color. You want about OY, not YY, OY. First about its own axis. Parallel side, 120, see little down, okay. 120 into 140 cube by 36 plus area, I will not waste time, half base into height into 80 plus this distance. See? So it is 80 plus this distance is 1/3 of 140, not 2/3. You should write 1/3 of 140. 140 whole square. Get the answer. Okay, next. Example number 3. Example 3. I will forget the distances. See, somewhere I will make a note. 80 and 140. 80 and 110 and 140 and 120. I will forget it. When I rub the sketch sometime, what happens is, every chance of forgetting that one. Here. Okay, now. See. Last time, this way triangle. Now, this way triangle. Now, this way triangle. Okay. This way triangle. Okay. Again, distance same. How much I told? This is same distance, 80. I want it not changing. This is 110, not changing. This is 140. Not. This is 120. This is 140. Okay, 140. This is the question. You write here. This is a given question for you. Triangle this way. Okay, now start. You make an independent question. This is the area. So, centroid. This is centroid. So, okay, start. First, I about OX. I about its own centroidal axis. 140 into 120 cube by 36 plus half into base into area into 110 plus this distance. Oh, 2/3 of 120, not 1/3, 2/3 of 120 whole square. This is to save the time, but you should take independent question. Don't do like me. Don't see the previous question. Some will tell, sir, same time. Don't see the previous question. Independently solve. Okay, start. I about OY. Because you are learning, I am teaching here. First about its own centroidal axis. 120 into 140 cube by 36 plus area into, see, into, last time I told you, last time, see, when you do I about OX, that area into, see, this distance square. Now area into this distance square or this distance square. 80 plus 1/3 of 140. Oh, same answer. What to do? It is same. Okay, over. Now, example is over. Now, last example is this way. Okay, all the cases are over. Example 4. See, I am covering each and everything, not leaving anything. Okay, this way. Once again, remember, this is given. This is 80, that is 110 given. This is 140. I am maintaining same because to save the time. Okay, this is a triangle. Start. First, as usual, see, this is your area considered. Mark centroid. Here, G. Start. First, I about OX. First, I about its own centroidal axis. 140 into 120 cube by 36. Plus area, half base height into from centroid to this axis perpendicular square. This distance 110 plus 2/3 of 120. Once again same. You should write once again. Okay. I about YY. OY, not YY, OY. First I about this axis. 120 into 140 cube by 36 plus area into, now it is area into what? From centroid to this axis, this distance square is 80 plus 2/3 of 140. See, these are all will give concept. By this today's class, you will learn everything about rectangle already over, triangle, three types of triangle, then circle, semicircle, quadrant, everything I am covering. That road sections I will cover it later. Okay, over now. Triangle over. Triangle now. Next triangle is case 2. Case 2 is, I will go for isosceles triangle. Spelling problem for me, unusual. Isosceles triangle. Okay. Question dictated. Now, this I will first write and start. Because sketch I will write. Case 2 for a triangle, isosceles triangle, question dictated. First example 1. Example 1 for case 2 isosceles triangle. This is a given. You write here. An isosceles triangle of base 250, height 100 and placed as shown in the figure. This edge at 90, this bottom edge at 170. These are given. See, 90 and 170 given. Base 250. It is told isosceles. So since it is 250, it is 125, 125. Now, this all I told you. Centroid is here. See, make a note. Isosceles triangle dividing into two parts is not required. Directly you can do centroid G here. Okay, start. First I about OX axis. First about its own axis. Parallel side 250 into 100 cube by 36 plus half into 250 into 100 is the area into, see, from centroid to required axis, see, this distance square. This distance square. Or you can mark here, see, mark here, light line if you want, this distance square. That is 170 plus 1 by 3 of 100 whole square. You get IOX. IOY. First I about its own centroidal axis. Oh, this you should be careful. Careful. Why? Because this is not the base. It is the common base for either side. This all I told already. I should not waste time now. So, still formula is what? Whatever is the parallel side here, 100 into perpendicular cube, 250 cube, but divide by 48. I told repeatedly for you, 48. Okay, over. Plus area into, from centroid to here, this distance square. That is half into, oh, I don't know why I wrote once again same answer here. Okay. Into this, see, into this distance square is 90 plus 125. Directly, center. 90 plus 125 whole square, you get I about OY. Okay, now, example 2. Same question, example 2. This way is the isosceles triangle. See, this way. Again, remember, this is 90. Height 100. Base is 250. Base 250. Since it's isosceles triangle, half. If I draw a light line here, both will be 125 each. 125, 125. Okay. Start. That here. Okay. I wrote here 250 over. Start. Mark centroid. Centroid is here. G. First I about OX. See, first I about its own axis. Pass into centroid. 250 into 100 cube by 36 plus half into 250 into 100 is the area into, see, from centroid to required axis, this distance square, or see, this distance square. That is 170 plus 2 by 3 of 100. Not 1 by 3, 2 by 3 of 100 square over. I about OY. First, about its own OY, its own axis. See here. Oh, same problem. It is not the base, it is common. I already told you 1000 times, leave it now. About this axis, formula is parallel is 100 into 250 cube by 48. Now I will not explain. Go back to earlier classes, study and come back. I told repeatedly 10, 15, 20 times I told. Plus area into, see, into what? This distance square is 90 plus 125 whole square. Same answer. Okay, calculate the answer. Answer is not required. Example 3. Okay, remember, I'll rub it out. Example 3 is here. Okay, I'll write here. Example 3. This number I will change now. See, this way. This base is same 250. 250 is the base. Height is 100, no change. Now base is this way now. And each half of is 125, 125. 125, 125. This you know it. 125. Okay, then this bottom edge from here is I am changing now. Not 110. I am changing it. This is 250, 165. And this distance from here to here is given 100, 148. Okay. This is 125. Some random number I am giving. 125, 125. Start. First, its centroid is here. See. G. Now remember, I will not tell again and again. I about this axis is, our base is 250 into 100 cube by 36. But I about this axis. But I about this axis is, see, this is not the base. How much it is? This is 100 into 250 cube by 48. You should know that one. So it will interchange here. Okay, I write once again. Start. First, I about OX axis. See, correctly understand. First about its own axis. Oh, this axis, you should be careful. You should be careful about this axis. How much about this axis? 100 into 250 cube. It is 100 into 250. Here, not there. 100 into 250 cube by 48. Then plus area into this distance square. That is 165 plus 125. 165 plus 125 plus 125 whole square. Okay. I about OY axis. First about its own axis. Oh, now this is the base. 250 into 100 cube by 36. 250 into 100 cube by 36. Plus area into, see, into from centroid of the component to the axis, this distance square means this distance square is 148 plus 1 by 3 of 100. 148 plus 1 by 3 of 100 whole square. You get I about YY. Now last one. Same question. I am not changing dimensions now. What I will do is, see. Out of scale, scale not maintained. Okay. This is 250. 250. Isosceles triangle. So both of them are 125, 125. I am not changing the other dimensions, 125. This I am maintaining same. And height is, I will mark here, this is 100, out of scale. Okay, start. Its centroid is here, see. Its centroid is here, G. First, I about OX. Now remember, about this axis, be careful. Be careful. About this axis, usual triangle. See, you can write here, usual triangle. Start. I about OX. First, I about its own axis. 100 into 250 cube by 48 plus area into this distance square is 165 plus 125. Oh, same answer as last time. But when you do I about OY axis, first I about its own axis. 250 into 100 cube by 36 plus area into, see now it is from centroid to axis this distance square. That is 148 plus 2 by 3 of 100. Some will tell, for sir it is very easy, change the numbers. Yes, why should I struggle by different numbers? You should do independently. You should not see the last time question. If those who are serious, they will take each and every separate question. Okay, over. Case 2 over. Now case 3 requires little attention. Case 3, that is a little problematic. Triangle in general. Triangle in general. This I will prepare the sketch for this one. I will prepare the sketch and start. Start now. Triangle in general, remember, very, very important for concepts of. Okay, start. Question example 1 for this case 3. See, there is a triangle of base 300, height 140, all in millimeter, and it is not isosceles triangle. The vertex, if you draw a perpendicular here, this is 120. Placed at 75 here and 250 here. This much is given in the question. First, those who are serious, those I told you, those who are serious, first write this way. Okay. Then write some statement. I will dictate now. All the 4 examples are there. Write the statement for all the 4 examples. Now, in this example, see, about centroidal horizontal axis, base is 300. So, no problem. 300 into 140 cube by 36, centroid is at 1/3 of 140. But YY axis will see, centroid will be where? You write here, centroid will be somewhere here. So, about this centroidal axis, there is no expression, standard expression for moment of inertia. Therefore, if you want I about OX axis, then no problem. See, if you want I about OX axis, oh, I think I interchange here. I about OX 75. Oh, fully, I don't know why it happened. 120 into 140 cube. Oh, see, this number is wrong. Again, same thing happened. What happened is, when I am writing here, I thought I am writing I about which one? Okay, no problem. I will explain once again. Okay. Okay. Right. Don't worry. Okay, now. But when we want I about YY, there is problem. Or no standard expression for moment of inertia for the axis passing to centroid and perpendicular to the base because it is shifted. You write the statement and then write, therefore, best option is write one more sketch. See, if you are lazy and if you do not do it, you are losing. Write one more sketch. If this is 120, you calculate this one, it is 180. Okay. Now, you do one thing now. See, separately consider this triangle and this triangle. Consider 2 right angle triangles. This way. Okay. Now, each of them, I will take, this is first one, second one. See, from here I will go. This I will take first 120 base, then 180. Number I won't give. Later you will put some number. 3, 4. See, in the big sketch, this may be part 4. See, some rectangle is there, already 1, some triangle already 2, maybe 3 and 4, like that. Okay, now, centroid. See, for this triangle, see, you write this way. Centroid is here. 1/3, 1/3. For this triangle, centroid is here. 1/3, but this is, see, this is 1/3, this is also 1/3. This is 1/3 of 140, this also 1/3 of 140. This is, I will do one thing, okay. I will put this is part 1 and part 2. Okay. Then this is your G1, this is your G2. Write this way. Start now. First, I about OX axis. First here, its own centroidal axis. See here. Right angle triangle, 120 into 140 cube by 36 plus area half into 120 into 140 into 250. See, from centroid to this axis, perpendicular square. See, this square is 250 plus 1/3 of 140. 250 plus 1/3 of 140 whole square. Okay, then come here. I about, we want what? OX axis. See, I about OX axis. First about its own centroidal axis. See here, its own centroidal axis. 180 into 140 cube, 180 into 140 cube by 36 plus area half into 180 into 140 into from centroid to required axis, this distance square you can make out for both same distance square. See, same distance square. Once again, it is 250 plus 1/3 of 140 square. Okay. Now, those who want can make a note here. Note. See, if the purpose is only to get I about this axis parallel to the base, then both the triangle, you can take single triangle, because then this CG is same this way. It is directly, you can write 300 into 140. You should write, see, if you wrote, you write. I am not writing, you write. Or directly 300 into 140 cube by 36 plus half into 300 into 140 into 250 plus 1/3 of 140 whole square. It will give same answer. You should write somewhere outside. Okay, now this you can do only for OX. See, when you want this axis, see both centroids in the same line. You cannot do it for OY. Okay, now come to I about OY. Now you have to split it. See, first about its own axis. 140 into 120 cube by 36 plus half into 120 into 140 into from here, see, from centroid here to this one, this distance square, 75 plus 2/3 of 120. 75 plus 2/3 of y 2/3, I will not tell, square, plus for this one. First about, see, its own centroidal axis here. Parallel side, 140 into 180 cube by 36 plus half into 180 into 140 area into from centroid here, see, from this centroid to OY, it is this distance square. That is 75 plus 120, you should be careful, 75 plus 120 plus another, this distance is 1/3 of 180 plus 1/3 of 180 whole square, you get the answer. See, IOY you have to split. Splitting compulsory. IOX you can avoid splitting, but actually what will happen is when you do a question later, confusion comes. Better split only. What is there to write this one? Okay, over. Example 1 over. Now I place this way. I will go for example 2. See what I will do. I will remember now how much dimensions. I will pick a note here. 120 and 140, 180, and this is 75 and 250. I will forget this. Distance I want same. Okay. Now I will not explain this much. Little fast I will do. Okay. Second question. placed this way. Okay. Write sketch here. See, in the question given, example 2, I will write here now. Example 2, okay. Millimeter not required, all dimensions millimeter. Why you are disturbing me? See, this base is 250. 250, correct? Yes. And this cut distance is 120. Actually, question given is like this only. 120, height 140, this is 250, this is 75. This is given as 75, same distance, to save the time, okay, for this one. Now, write a note here first. Again, problem, see, if you want I about x-axis, this axis, no problem. But this centroid will be somewhere here. Oh, problem, about this, no problem. Therefore, do one thing, you have to divide into, you first write the sketch, write the statement, we will divide into two parts, see, this way. One part here, one part here. I will call this as 1 and 2. Now this centroid, see, then if this is 120, this is 180, right here. How 180? Sorry, if not clear, leave the class. See, two right angle triangle, G1, G2. See, G1, G2 are same level, this way different. Okay, start. I about OX, first here. I about its own axis, 120 into 140 cube by 36 plus area into, see now, from centroid to here, see, this distance square, that distance is 250 plus 140, not over, see the 250 plus 140, we want, or no, not required, 250, you can directly do it here, from here to here is 250 up to here, plus this is 2/3 of 140. 250 plus 2/3 of 140. I first thought of telling you 250 plus 140 minus 1/3. Why? You can do from here only. This is 2/3 of 140, whole square. Don't forget. Last time I forgot to square. Don't forget to square. I forgot last time. Then here, first I about its own axis. 180 into 140 cube by 36 plus area into 250 plus, once again, 2/3 of 140. 140 whole square. Or, note, you write, directly you can do 250 into 140 cube by 12, full triangle, plus area into 250 plus 2/3 of 140. If you got courage, you can do it, but you cannot do it for YY. Okay, now start. I about OY. First about its own axis. This axis. 140 parallel. 140 into 120 cube by 36 plus area into 75 plus 2/3 of 120. It is, where is it? So once again same, 75 plus 2/3 of 120 whole square. For next one, see, I about this axis. For this axis, parallel side is 140. 140 into 180 cube by 36 plus area into 75 plus 120. See, from centroid here, from here to here, this distance square is 75 plus 120 plus 1/3 of 180 whole square. This is the example 2. Now I'll go for example 3. Here. This side, I'll face this side. Okay. First I want 1 and 2 here. Okay, that's all. Okay, no problem. That is my choice. How I take my choice. Distance I am changing now. Okay. Distance I am changing. That's all more. This way. Base you require, right? No space. Okay, base, Okay, now correct. Okay, space is there. Okay, this one. The base of the triangle is once again same. How much this base is same as last time? 250. And this distance is given as 250, correct? 250 means how? So not 250. It is 300, I think. Yes, it is 300. Or not 250, 300. Okay. 300. This is 120. Now, see, same as last triangle, but it is interchange now. Not interchange, turned. Okay, 180. You take independent question. This is for me to save the time. 180 over. And 180 is not given. This much given. Height given somewhere here. Height. Right last time? 120 height. Okay, 120. First write the sketch. Then write. See, here, centroid will be somewhere here. When you want to YY, there is no, now the note will come here now, not there. The note will come here. Now, when you want to YY, there is no problem. Y base is 300, but XX problem. Therefore, better you write the sketch and then write, therefore, better divide into parts. Make two parts here. One here, one here. Okay, last time green shading, this time black shading, no problem. Okay, now write this distance. This is 180. Now, mark centroid. See, this I will take 1, this I will take 2. Your G1, your G2. Okay, start. I about OX. First I about its own centroidal axis, parallel to OX. Now, base is 120, 120 into what? 120 into 140 cube. About XX axis, I about OX. When it is OX, how it is 120 last time? One nimisha. 120 into 140 cube last time. How it is 140 into 120? Oh, 1 minute. About this one. Last time it was this way. One minute. Interchange by chance. It is 120 into 140 cube. Height is 140, yeah? Oh, height is 140. Okay. I got confusion suddenly. So, I thought it is wrong. Okay. No, not wrong. 140 height. Now, okay. I got a shock of my life. Okay. Now correct. See. Now, I about first its own axis. See here. Now correct. See, got a shock of my life. How it is possible that I get confused? Okay, start. 140 into 120 cube by 36. You should not do this way. 140 into 120 cube, 140 correct, by 36 plus area, half into 120 into 140 into, see, from centroid to here, this distance square is, this distance how much? This distance is given in the question. How much was last time? 250. Okay, this time also 250 only. Okay, 250. Out of scale. 250 plus 2/3 of 150. 250 plus 2/3 of 120. See here. See correctly. This distance square is 250 out of scale plus 2/3 of 120. And for this one, I about first its own axis. What is 140 into 180 cube by 12. Not 12, 36. 140 into 180 cube by 36. Plus area, half base into height into this centroid from here is 250 plus 120. See here. 250 plus 120. What do you want? From centroid here to this axis, this distance square. You want this distance square is 250 plus 120 plus 1 by 3 of 180 plus 1 by 3 of 180 whole square. Why it's interchange now? What happened here? One minute. IOX. First 250 plus 250 plus. Oh, this is some previous one. Oh, writing problem. See, first once again, this happens always. When you want first one, once again, no problem. I about its own axis. 140 into 120 cube by 36 plus area into this distance square. 250 plus 2 by 3 of 120. Okay. Plus 2 by 3 of 120. Such things happen, see, whole square. Then second one, I about its own axis. How much it is? 140 into 180 cube by 36 plus area into this distance square is 250 plus 120. 250 plus 120 plus another from here to here is 1/3 of 180. See, I am also a human being. Sometimes number problem comes, what to do? There are so many 120, 140, 160, sometimes mix up. Okay, now start. Next, I about OY. First here. I about, see, its own YY here. Parallel side is 120. 120 into 140 cube. 120 into 140 cube by 36 plus area into, see here, this distance square is, where is the distance here? Where I given? This distance, how much I given last time? I can change it also. 75, okay. Out of scale, this is not 75, it looks very small. So do one thing now. Instead of 75, I will change it to 225, okay. Change the question. 225, so because space is there. So if I put 75, somebody will be laughing. 140 smaller, bigger, see. Into from here to here, see, from centroid to this axis is 225 plus 1/3 of 140. 225 plus, question changed. You take this question, what I gave you, take that question plus 1/3 of 140. 140 square. Then for this one, I about its own axis here. 180 into 140 cube. By 36 plus area into from centroid of this one to here, same as last time, 225 plus 1/3 of 140. 225 plus 1/3 of 140 whole square. Or you can write here, if you want I about OY axis, both the triangle, you can take a single triangle, 300 into 140 cube by 36 plus full area into 225 plus 1/3 of 140 also will do same answer. Okay, now example number 4, last example of this triangle. Same thing, I will get confused. 225, 1 minute. This I will not remove. 250 also I will not remove. Question first question. This is the question. 120, okay. Out of scale, what to do now? It's out of scale. Okay, I will put a sketch first. Okay, here. This way. Same. This is 140. See, this full is 250. Sorry, not 250, 300. 300 given. This is 120. This is on the later. First you write this much. This is a given triangle. This is 225 once again, same. I am not changing. 225 and 250. Okay. Right. Triangle in general, there is problem for I about not this axis problem. So you write first sketch, then write second time, then divide into parts. One part here, I will call 1. One more part here, I will call 2. Divide into parts. Now, start. See, for this triangle, G1, for this triangle, G2. Okay, start. I about OX first. First I about its own axis. See here, this way, parallel to OX. 140 into 120 cube by 36 plus area into, see, this distance square. See, from centroid of the component to the required axis. See, this distance square is 250 plus 2/3 of 120. Last time it is 2/3 of. Yes, correct. 250 plus, correct. 2/3 of 120 whole square. No change. But here, I about first its own axis. It will not change. Okay, start. How much? 140 into, you should write what is this dimension. See, you should write enter this dimension here, 180. Okay. 140 into 180 cube by 36 plus area into, from centroid here of the component to this axis, see, this distance square, that is 250 plus 120 plus 1 by 3 of 180, same as last time. Answer will be same, but YY will change. Okay, then next I about OY axis. Start once again first here, I about its own axis. 120 into 140 cube by 36 plus area into, see, from centroid here to the required axis, this distance square, that is 225 plus 2 by 3 of 140, not 1 by 3, 2 by 3 of 140 whole square. Here, same thing. Now you can do yourself only. I about its own axis. 180 into 140 cube by 36 plus area into this distance square is, once again, 225 plus 2 by 3 of 140 square. Okay, this will complete triangle in general. Now we'll go for next part, that is circle, semicircle and quadrant, closing part. I'll prepare the sketch for that one. I decided into preparing sketch. See, no sketch required for, nothing required for circle. Therefore, I will finish circle and then go to what? Prepare the sketch. Okay. See, I am still maintaining it. I am not changing it. Note, git all not there now. Okay. Start. Case triangle over now. Right here. Circle. Circle. Just example. One question. A circle of diameter. I'll give diameter for you. Diameter is 180 over. Place that from here some number 170. From here place that 145. Okay. This is a question. So easy. See here. First mark centroid. Okay. Put the sketch. Mark centroid G. This is a full circle. Okay. Start. First I about its own centroidal axis. How much it is? 5 by 64 of diameter 180 power 4. Circle is pi plus area. Pi by 4 of 180 square is the area into, from centroid to OX, this distance square, that is 170 plus half of the diameter 180 by 2. 170 plus 180 by 2 whole square. That will give IOX. Okay, right, IOY. First about its own centroidal axis here. Once again same. How much? 5 by 64 into 180 power 4 plus area 5 by 4 of 180 square is the area into I about OY you are doing from centroid to this axis. See, this distance square is 145 plus 180 by 2 whole square. 145 plus from here to center is half the diameter over. Circle is over. Okay, now next is semicircle. I'll slightly clean the board. Looks a little dirty. One ನಿಮಿಷ. Slightly I will clean it. Okay, now. Next, semicircle. Semicircle, example 1. Okay. Imagine here, this is the OX axis, this is OY axis, OXY. There is a semicircle here, see here, this way. Okay. Diameter given in the question, diameter is 160 diameter. This distance is some 85, and this distance given is 85. This is say 85, little bigger, 148. Okay, this is the question. Start now. One I will start now. IOX. Okay. Now first step. I explained everything. First mark centroid. See here. I won't explain. See, this is center here. Centroid here. Remember, this way midpoint, this way is 2d by 3 pi. I will not explain now. There is a limit for explaining. This is 2d by 3 pi. It does not look like semicircle here. What is happening? Okay, now okay. Now okay. Little shifting here. Okay. Okay, that's all. You don't bother. Okay, now correct. Okay. 85. You don't bother about the neatness of the sketch. Here, centroid G. So one axis here, one axis here. Remember, this way center, this way is 2d by 3 pi. Okay, now 1 minute. See, this is symmetry axis, therefore happy case. This is not symmetry, therefore be careful. Be careful. This all I fully explained for you. Now I will not explain. There's a limit. This is application. No one should ask, sir, how you got the answer? Then what you are doing in previous classes. Okay, start. I about OX. First about its own axis. That is, symmetry is not there. Semicircle, 0.00686 into diameter power 4, 160 power 4 is Ig. I told you, for this one, 0.00686 d power 4 plus area, circle is pi by 4, semicircle is pi by 8 of diameter square. 160 square is the area. That's the space problem here. Okay, 1 minute. I'll write this. Right. This is the space problem. 1 minute. I'll tell you why space problem. IOX equal to space problem, because when I go to next one, it requires little more length here. I may go out of the board there. I don't want to go out of the board there, or adjust the camera. Okay. Okay. Now here, I about XX. I'll write once again. I about OX equal to 0.00686 into 160 power 4. This I told thousands of times. See, this is not symmetry. So if not symmetry, semicircle is 0.00686. All told earlier, go through 100 times. Plus area, pi by 8 of 160 square is the area into, very important term, see, from centroid to OX, this distance square is 148 plus this distance is 2 times diameter divided by 3 times pi whole square. Okay. I about OX over. Okay. I about OY. First about its own axis. Oh, this is symmetry axis. So if symmetry is there for semicircle, IG is pi by, circle is pi by 64, semicircle is pi by 128 into d power 4. This all told for you. Area Ig plus area, pi by 8 of 160 square is the area into from centroid here to OY axis, this distance square is 85 plus this distance is half of diameter into 85 plus diameter is 160, 160 by 2 whole square. You get I about OY. Okay, now, same question once again now, example 2. How much I told here? 85. Okay, I won't change it. 85 I won't change because easy for me. 85. Diameter is to 160. Okay. This way semicircle. Okay. Somewhat 85. Okay. Okay. Adjust ಮಾಡ್ಕೊಳ್ಳಿ. Adjust it. Okay. From here is 85 up to here. This is 85. Once again I am telling diameter is 160. 160. See, start semicircle this way. First centroid. Centroid is here. G. This is axis, symmetry axis. Therefore, very happy case. This is be careful. This is be careful. Start. I about OX. First I about its own axis. Same, 0.00686, diameter power 4, plus now area into C. Now it is, this distance square is 1, see, this is 2D by 3 pi. 148 plus from here to here is half of diameter plus 160 by 2, that will give you distance from here to here. See, 148 plus 160 by 2. Now subtract 2D by 3 pi minus 2D by 2D by 3 pi, right, substitution, 2 into 160 divided by 3 pi whole square. Okay. I about YY. First about its own YY. Happy case. Same. Pi by 128, 160 power 4. Area into this distance square is 85 plus half of 160. Same as last time. Now, question number 3. 85, 148. I'll forget it. 85, 148 and diameter is 160. Dia. I want to maintain same to save the time, that's all. Now next, this one, which is 85, this is 85. See, this way. Diameter is 160. This distance is 85 out of scale, and this distance is 148 out of scale, given in the question. This is a question given. Example number 3. Start. First, its centroid is here. Now remember, this is one of the centroidal axis. This is other axis. This axis, happy case, why? Pi by 128 d power 4. But this axis, be careful. Be careful about this axis. Start. I about OX. First, I about its own axis, happy case. It will interchange now. See? Pi by 128 into 160 power 4 plus area into, see, from centroid G, from here to here, this distance square is 148 plus half of 160. 148 plus 160 by 2 whole square is the answer. Next, I about OY. First about, see, here, its own axis. Be careful, its own axis. That is, about this axis is 0.00686 into 160 power 4, diameter power 4. This is IG plus area into, see, this distance square is 85 plus 2d by 3 pi. 2 into 160 divided by 3 divided by pi whole square. That will give I about OY. Now, example 4. What I am doing? Okay, this way. Okay, out of scale now. Okay. I should bring it here. Now, okay. Some will tell he is not maintaining scale. Why should he bother about scale or? Okay. Semicircle, somewhat. This is 85, not changing. 85, this much, how much I told? 148. This I am not changing. This I am not changing. Okay, now, diameter 160. 160. Mark centroid. Centroid is here. This is no problem, happy case, but this is problematic. This is, be careful. This is 2d by 3 pi, start. I about OX, first I about its own axis, same, pi by 128, 160 power 4, area into, see, this distance square, 148 plus O, same as last time. But when you do I about OY, first about its own OY, same as last time. Area into, now, see, it is this distance square, that is 85, not over 85 plus this distance is half of 160 by 2, see, 160. 85 plus 160 by 2 minus 2d by 3 pi. Minus 2 into 160 divided by 3 pi. Close. Square over. This will give I about OY. Now lastly, quadrant of a circle. I will do one thing now. I will write 4 sketches in a single page and explain. Come to the closing part. Quadrant of a circle. 4 example. See 1 by 1. Example 1. A quadrant of circle this way. See, diameter 145 given. 135, 95 given. G is not given. G we are marking. Green color we are marking. Okay, mark G. Those who want, make a note. 2d by 3 pi, 2d by 3 pi. Okay, then I about this axis and this axis. This time, both be careful. Both are 0.00343 diameter power 4 and area is pi by 16. That much you should know. Start. I about first. I about OX axis. First I about its own axis. 0.00343 into diameter 145 power 4 plus area pi by 16 145 square into from centroid to this axis. See, this distance square is 135 plus 2d by 3 pi. 135, what happened? Oh, it's interchange here. Oh, I don't know why it's happening. 135. Okay, 135 plus 2 into diameter. How much diameter? 2 into 145 divided by 3 pi whole square. When I start writing, I first thought I am doing OY first. Okay. Then I about OY axis. First about its own axis. Same, 0.00343, 145 power 4, area same into, see, this distance square is 95 plus, how much? 2d by 3 pi. 2 into 145 divided by 3 pi whole square, you get IXX, IYY. So this question over. Now come to example 2. I will save some time. I know how to save the time. See, okay, now one question over. Remove this one. Example 1 over. Go to example 2. Same way, semicircle is placed this way now. Okay, same dimensions given. Be careful. Start first. I about OX. First I about its own axis. 0.00343. Once again you have to write. Last time it is there. Once again I am now writing for this one. 0.003, 0.0343, 145 power 4 plus area into, see, this distance square. That distance is 135 plus once again 2d by 3 pi whole square. Same as last time. I about OY. First about its own axis. 0.00343 into 145 power 4 plus area into, this is 95. Sorry. Not this. I about this one. I about OY. Okay. First I about its own axis area into this distance square. See, I told this one. No. That is for OX. For OY, this distance square is 95. This is 2d by 3 pi. So 95 plus this full distance is how much? 95 plus this is radius 145 by 2. See, 95 plus diameter is 145, means is 145 by 2 will give you from here up to here. Then subtract minus 2 into 145 divided by 3 pi whole square. That is for example 2. Example 3 I will write here. Example 3. Hmm. 135. Okay. Not required. Scale is not required. Okay. This is example 3. Downside. Again given diameter is 145 and this distance given is in the question 95. This distance given is a given question 135. Okay. This is example 3. Now don't see that one. Don't see that sketch. See, its centroid is here. Again now, be careful about both. Y here. How many times you have to write? X here. G. Start. First I about OX. I not OX here. Okay. XY. First I about its axis pass into centroid parallel to OX. This axis. Same. 0.00343 145 power 4 plus area. Area is pi by 16 145 square into, see, from here to here, this distance square. That distance square is 135 plus diameter by 2, 145 by 2 plus, not plus, see, 135 plus this radius, diameter by 2, minus 2d by 3 pi. Minus 2 into 145 divided by 3 pi whole square will give I about OX. I about OY. First about its own centroidal axis. That is this axis. Same. 0.00343 diameter power 4 area into 95. See here. 95. We want from here to here. See, this distance square. 95 plus this half. How much half? Half of diameter. 145 by 2. This full distance minus 2d by 3 pi whole square. This will give question number 3 over. Lastly, question number 4. Same time. However, now first is up the lower side. Now how I do? Next I had to put this way. Yes, this way. Okay. Now here. Okay, this way. It's a quadrant. Okay, over. See, once again, it's out of scale. Okay, no problem. Don't bother about those things all. This is given 135. Out of scale. Don't laugh. This is given 95. Out of scale. Diameter is 145. Remove this sketch. This is not there. Now, this is 135, 95. Okay. This is not there. Example 4. Everything covered now. Example 4. Start. Its centroid is here. See, this is x axis, its own x-axis. its own axis. Start first. This is centroid G. I about OX. First I about its own axis. 0.00343 diameter power 4 plus area into from centroid to this axis, this perpendicular square, that is 135 plus half of 145 full distance minus 2d by 3 pi whole square. You write once again. Okay, lastly, I about OY. I about OY. First, I about its own axis here. 0.00343, 145 power 4 plus area into from centroid to this axis. See, 95, to save the time, 95 plus this distance is 2d by 3 pi whole square. So, remember today's class, this 0.00343 pi by 128 and BH cube by 36, not for that purpose. Today's class is for application of parallax theorem. So, that all you have to thoroughly go through earlier classes. Suddenly somebody coming to this class, he will tell how it is 0.00343. If anybody will tell in front of me, you know what I will tell? Leave. No, you are not eligible to study from me. So therefore, now everything is over. We will seriously start moment of inertia. Before that, I may upload one more class now. See, something like this. Some lamina I put here, lamina put here, lamina put here, lamina put here, lamina, etc. I may explain. Depends, actually not required. I will decide now, is it required or not required. If required, one more class, extra information I will give you. Then we will start seriously moment of inertia calculation. Okay. Go through each and everything in today's class, including last class, for that matter, right from the first class of engineering mechanics. Okay, thank you.